I'm Jan Ozer. Thank you for coming. Today we're going to talk about encoding for iDevices, quite loudly, it sounds like. Perhaps we can turn that down. Too loud in the back? Good for y'all? Okay. I am on the computer over here uploading the PDF that I'll be using for the presentation. And you can go to streaminglearningcenter.com, and I would show you how to go there on this computer, except I don't quite know how, since it seems stuck on PowerPoint Presenter. So streaminglearningcenter.com, or if you want to come up after, I can show it to you on this computer here, but it's uploading now. So we've got about an hour. And here's what I'm going to cover. H.264 is the best codec for encoding for iDevice delivery. So we'll spend some time looking at some fundamentals to H.264 encoding. And then we'll look at two use cases when you're encoding for the iPad and the iPhone. The first one is tethered delivery via iTunes. So we're going to look at a lot of downloaded iTunes files or a lot of statistics from those files to see how people are configuring video. Are they ignoring the older devices? Are they producing 2 files? Are they producing 1080p? And then we'll switch our attention to adaptive delivery via HTTP live streaming. And then at the very end, we'll cover single file delivery to connected iPhones, iPads, and iPod Touches. So that's kind of the agenda for the next hour. Now, what is H.264? H.264 is a compression technology. This is obviously the most confusing screen I could find. This is the codec selection screen from Sorensen Squeeze. And what we're seeing here is we're seeing two basic kind of codecs. We're seeing the main concept, H.264 codec, up here. We're seeing the Intel QSV codec, that's a hardware accelerated codec here. We're seeing main concept again here. We're seeing main concept CUDA, which is also an H.264 compression technology accelerated by NVIDIA graphics cards, and we're seeing X.264 here. So all these are H.264 codecs, and all of them are good choices, except for Sorensen MPEG-4. So MPEG-4 video files will play. That's way too loud. Can you turn that down, please? MPEG-4 videos will play, but it delivers about half the quality that X.264 does. So if you're producing for iDevices, you should use H.264. And that's the only codec you really need to know about. Now, what are profiles and levels? There's literally dozens of H.264 encoding options, but most of them impact quality. And if you mess those up, maybe your quality's a little bit suboptimal, maybe your data rate's too high. Not a big deal. If you mess up profile and level, the files that you produce won't play on the target devices. So really, when you're producing H.264 for iDevice delivery, the things you need to know when you're encoding your files are what is the profile and what is the level. And this is an encoding screen from Adobe Media Encoder. It's pretty representative. Pretty much every encoding tool out there will give you direct control over the profile and the level. And those are the ones you really need to know about when you're producing for iDevices. So what are the H.264 profiles? There's pretty much 3 that we worry about when we're producing for computer playback. There's baseline, there's main, and there's high. And this is the definition from Wikipedia. It says that a profile defines a set of coding tools or algorithms that can be used in generating a bit stream. So these are all the coding tools and algorithms, and these determine which can be used for each profile. So you would look at this and you would make the assumption, okay, this is the baseline profile, this is the high profile. The high profile uses more of these advanced encoding tools, so it's going to produce a higher quality file. That's the assumption you would make. The other assumption you would probably make is this file is going to be harder to play back because it uses all these advanced encoding tools. So, and that's the fundamental trade-off. When Apple came out with the first video-capable iPod, they supported the baseline profile, which meant only these encoding capabilities. Why? Because the CPU that they put in the original iPod needed to be inexpensive, needed to be small, needed to be not highly power consumptive. So they used the baseline profile. They wanted H.264 video, but they couldn't afford power-wise, space-wise, cost-wise, a CPU that would play the high profile. So really, that's what the different profiles do. Different iDevices support different profiles, and when you're making a decision as to which iDevices you want to support, you have to know which profiles they play, and we'll look at that in a second. So the profiles determine which algorithms can be used, as we see over here, and if you encode it the wrong profile, it will not load on the target device. Levels constrain key parameters in the bit stream. So if you're encoding to level, say, 1.2, you can't exceed 384 kilobits per second, 480 kilobits per second for the high profile, and your resolution can't exceed 320 by 240. Okay, so profile is the algorithms, levels are the resolution and the data rate. And what Apple does is they define the playback capabilities for each device in terms of both profile and level. So when you're producing, you need to make sure that you don't exceed those levels. Basically, the routine is, we're going to look at this in detail in a few moments. You know, you pick out your devices here. You say, I want to support the original iPod if you're producing podcasts. I want to support the original iPhone if you're producing for connected delivery. And then you need to say, okay, well, what profile and level can it support? And then you need to make sure that the files you produce for those devices don't exceed that profile and level. And basically what I recommend is you find an encoding tool that you trust, and pretty much all of them do a good job with this. You pick a template that says, okay, I want to support the original iPod, I want to support the iPad 3 or the new iPad, and then you don't adjust the profile and level on that template. So that's H.264. Again, we're going to look at two scenarios, video podcasts, which we'll cover next, and then streaming delivery to iDevices, which is best done with HTTP live streaming, which we'll cover after we cover the podcast market. So this is kind of worth the price of admission. You know, this summarizes, in terms of basic groups, the playback capabilities of all the classes of iDevices. And again, this will be, you know, this is hopefully uploading now, and it'll be available on my website. If you want to see the URL, I can show you after the class is over. So this is the original iPod to the 5th generation original iPod. This is not a connected device. There's no wireless, there's no Wi-Fi. The only way to get video here is via tethered delivery via iTunes. Those original devices can play baseline profile up to level 1.3, which is a max video resolution of 320 by 240. And what's interesting is that when I looked at the podcast market, there are many producers who still produce files that play on these devices. So these first came around, I mean, I forget what year it was, probably early 2000s. A lot of, I don't want to say a lot, but 7 or 8 producers still produce files that will play on these devices. The next step up, the iPod Nano, iPod Classic, iPod Touch, iPod Phone through version 4 can do baseline through level 3.0. That will play a file up to 640 by 480 resolution. That frame rate. AAC is the MPEG-4 audio compression technology. It will play AAC-LC, low complexity, up to 160 kilobits per second. And the vast majority of files that you see encoded on iTunes, and even for streaming delivery, are pretty much customized for this level and above. Any file that will play here will obviously play here. It may not look as good as you'd want it to look, but you get compatibility. So there's a lot, most producers, probably 97 to 98% of producers are producing for this level and beyond. And we'll see that when we look at the iTunes statistics. Level above that, the iPhone 4, the iPod Touch 4, and the iPad 1 and 2 can play main profile through level 3.1 at a maximum data rate of 14 megabits per second, and that's 720p video. So that's 1280 by 720. And up until the introduction of these two products, most of the podcasts that we saw for Hollywood TV shows, Hollywood movies, maxed out at 720p. Then came the iPhone 4S and the iPod 5, the iPhone 5 and the new iPad. They can play high profile through level 4.1, which gives you 1080p video at up to 50 megabits per second for the iPhone 4S and 62 megabits per second for the iPhone 5 and the new iPad. Now, nobody goes close to these numbers, but those are the maximum capabilities. Now, I pulled these specs from the Apple website, and Apple does a great job defining the video playback specifications for every device that they produce. What's interesting is that all of these devices supposedly support a maximum audio data rate of 160 kilobits per second, but every music video that I downloaded, which we'll see in a second, was compressed to 256 kilobits per second. So I'm not quite sure what Apple's doing with these, but a lot of the limits that they show here aren't true hardware limits. They're just the published limits. So I'll tell you what they say you should do, and then I'll show you what other people are doing, and you can kind of draw your own conclusions. Okay, so covering tethered delivery via iTunes. Let's look at the decisions that you need to make, which devices you want to support. Do you want to support multiple files? And then we'll get to encoding recommendations for 320/240 or 320/180, 640 by 360 or 640 by 480, and then 720p. So decision 1, should you abandon the older iPods to play only 320/240? Decision 2, should you support the post-iPod 5G devices with a single max 640 by 480 stream? Or should you produce multiple streams? And then, should you distribute 1080p files to devices that support them? So we'll take those one after another. So what I did to produce this survey of mine is I downloaded 52 free files from iTunes US and 17 files from iTunes UK. So a total of about 70 files. And I looked at all the three-letter networks, CBS, NBC, and Prominent Technology and other sites. Basically, I tried to get a good grouping of different types of content to see how they were encoding their videos. And I did get some BBC videos as well. And these, again, are all free downloads, and we'll look at the paid downloads separately. So what I found was 6 of the 52 files were 320 by 240 or lower. Means they will play on the oldest category of iDevices out there. So this was Oprah in the US, this was Oprah, Face the Nation, Techzilla, had 2 of the 6. And in Europe, 2 of the 17 were 320 or 240 or lower, and that was VH1 and Kettlebells Fitness. So there are still some producers who are trying to reach everybody. Some people are doing it with one file, and then Techzilla and Cartech, these are Revision 3 websites. It's an internet broadcasting company. They're serving their customers with multiple files. So they distributed both at 320 by 240 and at a higher resolution. So if you're seeking the broadest possible audience, don't abandon the oldest devices. Should you support post-iPod 5G devices with a single stream? So 28 of the 52 podcasts were 640 by 480 or 640 by 360. That was the biggest grouping. So most people are focusing on that, this core group right here. And they're saying, maybe we'll forget about these people, but we're definitely not going to forget about these people. So 640 by 360, 640 by 480 is by far the most widely configured stream. And in Europe, so in the US it was 28 out of 52, in Europe it was 12 of 17. For most producers, this was the only stream. So, unless you have a strong reason to produce at 720p, and we'll cover a couple of use cases in a moment where I think it would be compelling, a single 640 by 480 stream or 640 by 360 stream should be fine. Should you distribute multiple files? As I said, Revision 3, CNET, and This Week in Tech, all high technology sites, they use multiple files. So if you're a tech site, I think your users are technical. They expect more variations in the files. They want files that match the playback capabilities of devices that they have. If you have compelling HD content, so there was NASA in the US had some beautiful space footage or beautiful launch footage, that's the stuff that makes sense to produce in HD. You know, if you have a talking head of your CEO or a talking head of a product manager, that's probably not so compelling. And then the third class was screen cams. So if you're producing screen cam type videos, those don't really look well at 640 by 360. You start to lose a lot of detail. So you may want to produce one screen cam encode for older devices at the 640 by 480 and then a 720p version as well. I would recommend that if you offer a 720p file, you should offer an SD file as well. And you know, in the survey that I did, 4 of 10 producers who offered a 720p stream also offered a lower resolution stream. Should you encode at 1080p for the devices that support it? This is the iPhone 5 and the newest iPad. None of the free podcasts I found were 1080p. I'm sure they're out there because there's TV shows that I downloaded that were 1080p, but none of the free podcasts that I downloaded were 1080p. Okay, so that's we're going to come back to recommendations for encoding in these classes in a minute, but I wanted to take some time and look at some paid content. So these are music videos, and these were, you know, music videos that I purchased from iTunes, right? And they're pretty much the top 10 or the top few music videos. I wanted to make sure I got the most current videos out there. And all of them were produced, so the width is 640 by 352 or 480, and the profile is all baseline. So what does that tell you? Everybody producing music videos is going after, again, this group here and above. And interestingly, the music video crowd produced one file for all of these. They didn't produce a 720p file. They didn't produce a 1080p file. They just produced one that would play here and play everywhere else. And the average data rate was about 1.5 megabits per second, and the average audio data rate was 256 kilobits per second. So even though the maximum published data rate in the Apple specs was 160 kilobits per second, every music video that I downloaded was 256 kilobits per second, and they all loaded and played fine on the devices that I tested. So I don't know if you can hear the difference between 160 kilobits per second and 256 kilobits per second, but apparently if you're selling a song for, you know, $2.99, you're going to want the best possible audio quality that you can deliver. Now this is pretty technical, but I figured I would kind of describe it. These files are all, so 640 by 480 is a 4:3 aspect ratio. And there's a lot of 4:3 aspect ratios in these videos. You know, here's Jennifer Lopez, 640-480, Christina Aguilera, 640-480. These were all produced at an aspect ratio of 16:9. So what they did was, and this is the Katy Perry video, if you analyze the file in media info, the number of pixels in the file was 640 by 480. Now, why did they use 640 by 480? Because if they used anything bigger, it wouldn't play on that massive group of iDevices that we talked about. On the other hand, when the file displayed, it displayed at 853 by 480, which is a 16:9 resolution. So in their encoding tool, they said, encode it 640 by 480, but an aspect ratio of 16:9. And that's how they produced a 16:9 video here. And it's a pretty cool way to get 16:9 looks in a file that will play on older iDevices. Now, I know how to do this in Compressor. I know how to do this in a couple of other encoding tools, but I'm not sure every encoding tool can do this. You may have to play with it, but it should be possible. So that's a fun technique that I saw not only with music videos, but every Hollywood TV show that I downloaded, or Bollywood or BBC, all produce their SD versions at 640 by 480 with a 16 by 9 aspect ratio, duplicating this schema. So you can get a 4:3 file that plays on those older iDevices, but expands out for higher resolution playback on iPads and iPhones with the 16 by 9 like screens. Okay, HD TV episodes. We're going to look at 3 groups of these. This is 2011, November, pretty much last year. And this is pre-new iPad, pre-iPhone 5. Every show was at 720p, okay, at a data rate of about 4 megabits per second. You know, at their native frame rates, some were 25, some were 24, some were 29. They minded the audio data rate limitations. You didn't see anybody going over 160 kilobits per second, and they were all in stereo. So this is pre-new iPad, pre-iPhone 5. And in October of 2012, we saw a bunch of 720p videos that also pretty much matched the same specs, around 4.1 megabits per second, 152 kilobits per second average audio data rate. So these, again, are paid TV episodes downloaded that were HD. And then HD TV episodes, again, October 2012, again, paid TV episodes. We start to see 1080p really hit the market. So if you're producing an HD show, it's a television show or a movie content, and you're distributing it or selling it on iTunes, you need to start thinking about a 1080p file version. And this was encoded, you know, averaging around 1080p, around 5.1 megabits per second. Again, none of the producers exceeded 160 kilobits per second. These are the SD episodes that I talked about. So the Hollywood studios are very mindful of the fact that there's a bunch of folks out there who can't play files above 640 by 480. So they produced, you know, this is, in iTunes you can configure your preferences for downloads. And if you configure it in SD, these are the files you would get. And the average, again, was 640, 480, 1.5 megabits per second, 128 kilobits per second. One of the TV shows exceeded 160 kilobits per second, but most of them were well under that. Again, all were in the baseline profile. And let's take a step back and look at profiles. You know, here, all the 720p files were produced using the high profile. And if we went back to that table that I've showed multiple times, we'd see the devices they were targeting can play high profile. Again, if you're producing 1080p video, you're going to want to use the high profile as well. So these files obviously will not play on the earlier versions of iDevices. Okay, so if you're encoding music videos or television videos, I would come back to these and use these figures for guidance. Okay? There's enough statistics here that you can look at them and say, okay, I'll just use the average number that they're using or the highest number that they're using. If you're producing for general iTunes distribution, this is a company video or a club video, and you're not selling it, you're just putting it out there. This is the average data rate. So we talked a little bit about the survey. I downloaded 70 files. For the files that were encoded at 320 by 240 or lower, the average data rate was 532 kilobits per second. The average audio data rate was 95 kilobits per second. So if you're producing podcasts at 320 by 240, I would ignore what the template does in Squeeze or in Compressor or in whatever tool you're using, and I would put in a data rate target of 532 kilobits per second with a maximum data rate of 768, because that's the maximum of the device. So I would go to my preset for, that I'm using for this class of iDevice, and I would make sure it supports the baseline profile or uses the baseline profile. I would make sure that the average data rate is around 532 kilobits per second and doesn't exceed 768. For the 640 by 480 or 640 by 360 class, once again, this is free iTunes distribution, we saw that for SD television and for music videos, this number was around 1.5 megabits per second. The average data rate in the 70 free iTunes podcasts that I downloaded that were in this class was around 1.139 megabits per second. The device maximum is 2.5 megabits per second, so you should encode, set your target at this, set your maximum at this. And the average audio data rate was around 113 kilobits per second. 720p, which is the highest I saw for free podcasts. The average data rate in this group is around 2.9 megabits per second. The device maximum is around 14 megabits per second. And this is the one area where, if you looked at the compressor preset for this category, the maximum data rate in the preset is 14 megabits per second. So they would encode your files at 14 megabits per second, which is 4 times more than most people are using. The file doesn't look any better because it looks fine at 3 megabits per second, so that's the number I would target. And the average audio data rate was 169 kilobits per second, which again exceeded the specs of all the iDevices. Okay, any questions on podcasts? Okay, so let's talk about encoding for adaptive streaming. Talk about HTTP live streaming to iOS. I know this session is about iDevice delivery. If you produce using HLS or HTTP live streaming, you also get Android 3.0 devices and above for free because they also play HLS devices at this point. We'll talk about that, and then we'll talk about transmux strategies, and then we'll look at single file encoding. So what is adaptive streaming for the people? I'm sure most of you know what it is, at least in theory. Basically, you produce multiple file iterations. You have one source file at 1080p, and then you distribute, or you encode that file into multiple iterations, perhaps ranging from 1080p to 720p to 850 by 480, 640 by 360, and then a 320 by 180 file for really low bitrate delivery. The benefit of doing that is that if somebody's watching in their living room on their Roku box with a great big LCD screen and a very fast internet connection, they get a great quality experience. If somebody's watching on an iPhone, they get a lesser experience, but it still plays. So if you're distributing to mobile devices today, adaptive delivery has to be something you're either using or considering because you've got so many people viewing over cellular connections that if you don't use adaptive, you can't really reach those, and you can't produce a stream that satisfies both those people and people watching on high-resolution screens. So, adaptive streaming, it adapts to the changing conditions. Not only can it create a file for iPhone delivery and a file for delivery in the living room, but if conditions in the living room change, if bandwidth goes down, it can send a lower quality stream to the living room as well. So the connection doesn't break, the video stops playing, the quality may drop a little bit, but it's going to continue to play. And all this is transparent to the viewer. We're all familiar with the YouTube style of choosing your video quality. You go down to the lower right-hand corner and click and choose a 720p or 1080p. Adaptive streaming using HLS, and in fact most technologies, is all transparent. Viewer clicks one link, video starts to play, adaptive delivery occurs in the background. So if you're distributing to iDevices, the sole adaptive streaming technology you can use is HTTP live streaming. And as I mentioned at the top, it's supported in Android 3.0 and 4.0, and that's about 40% or about 30% of Android devices out there today can play HLS files. So we'll talk a little bit about how it works, and then we'll look at how to customize your encoding for HTTP live streaming. So here's how it works. You've got your audio video input here. You encode that into H.264 format. Then you send it to a stream segmenter that produces an MPEG-2 transport stream and an index file. And we'll look at more detail on this index file and transport stream structure in a second. And then you post the manifest files and the content files to a video server, and then the player looks at the server to find the location of the alternative streams. And again, we'll look at that in more detail in a second. The client, which is your iPhone, your iPod, your iPad, monitors the playback buffer. If the playback buffer starts to contain less and less video, it will request a lower quality iteration. If the buffer's fine, it will request a higher quality iteration. And then here's how the index file works. You know, you've got one main index file, and that's called the M3U8 file. And that contains the locations of the sub-manifest files. So in this case, there's 3 streams. Here's the main index file. Here's the low-quality alternative, the mid-quality alternative, and the high-quality alternative. And here are the file chunks associated with each stream. So when you click a link on your iPhone, you go to this file, and you select, say, the mid iteration, and then you retrieve this chunk here. So the player's doing everything. There's no server involvement. There's no streaming server involvement. The player is in charge of monitoring the playback buffer and then changing the streams as necessary to maintain continual playback. So if the video starts here and the buffer's good, the player says, okay, where's the next higher quality stream? So it checks this file here, and it says, well, the next higher quality stream is here, and it downloads chunk 2 from that file location. So the manifest file here and the manifest file here contains the chunk names and the chunk locations on an HTTP server. And then the player, the iPhone over here, is in charge of retrieving the files as necessary. So we were playing over here. If bandwidth drops, the iPhone says, holy cow, I need a lower quality stream, checks the index file, where's the location of the low quality manifest file, checks here, and downloads this chunk, you know, the 3rd chunk in the low quality stream. And that's how stream switching occurs within the HLS structure. Very elegant, very simple solution. And again, it doesn't involve a streaming server. So there's no, you don't need the Wowza server, you don't need the Adobe Media server, you don't need any streaming server at all. You just use a standard web server, which is why it's called HTTP live streaming. Now, the original version called Basic Streaming for iOS and OS X, it broke the content files into separate .ts chunks. TS stands for transport stream. HLS uses the MPEG-2 transport stream as the container format for the files. There were many, many, many chunks, you know, millions of them sometimes. You know, if you had a 3 or 4 hour event, you had 7 or 8 iterations. The individual file chunks were very, very hard to keep track of. So with iOS, with the latest version of HLS, which is playable on iOS 5 and higher, Apple adopted a single TS file with byte ranges in the playlist. Basically, instead of seeking a separate chunk, you would see one file with addresses for the chunks in the file. So it's a more elegant solution. It's how Microsoft does it with smooth streaming. It's how Adobe does it with HTTP dynamic streaming. And it really simplifies using HLS. If you want more details on that, you see the reference here. Okay, so if you're producing for iDevice delivery, you have to use HTTP live streaming. Let's look at some of the decisions you have to make when you do that. And there's 2 aspects. Number 1 is, what's the stream count and configuration? How many streams should you use? How should you configure them from a resolution and data rate standpoint? And then it's, okay, how do I customize H.264 encoding to make sure that the files work well in the HTTP streaming schema? Okay, so Apple, again, makes it very simple to implement. If you go to this URL here, you will see their best practice guidelines. And this is 16:9 aspect ratio content. And they do a nice job of suggesting dimensions, the total bit rate, the video bit rate, keyframe interval, and the profile. And then they tell you what devices this stream will play on and won't play on. Okay, so anybody producing for HTTP live streaming should start here. You know, very few producers use these recommendations as is, but if you're just starting out, I think it's the most appropriate place to start. A couple things to notice. Here's the total bit rate. Here's the video bit rate. So the difference here is 150 kilobits per second, 110 kilobits per second for video. Obviously, the difference is audio. So we see a 40 kilobit per second difference between the 150 and the 110. We see a 40 kilobit per second difference between the highest configuration, 720p. The total bit rate is 4540. The video bit rate is 4500. So basically what Apple is saying is use the same audio bit rate for all streams. And we'll cover that in a second. I just wanted to point that out on this chart. That is the most conservative approach. If you look at what MTV does, if you look at what other producers do, some people change the stream to match the video quality, and we'll talk about that in a second. The other thing is the keyframe. So the keyframe interval here is 30. The keyframe interval here is 45. The keyframe interval here is 90. Now, I'm going to tell you in a few minutes that the keyframe interval should be identical in all the files you produce. Why? Because you switch those chunks, and those chunks have to start on a keyframe. So why is this 30, why is this 45, and why is this 90? Because this file is encoded at 10 frames per second, this file is encoded at 15 frames per second, and this file is encoded at 30 frames per second. Okay? So the keyframe interval in seconds, which is what you care about, is 3 seconds, 3 seconds, and 3 seconds. Okay, does that make sense? Okay, and then here, Apple's basically saying, create your lowest quality streams to play back on these targets, meaning don't exceed the maximum resolution, don't exceed the profile and level, and then step it up a bit in terms of quality for the iPhone 4, the iPads 1, 2, and the new iPod, or the new iPad. And Apple does a nice job of keeping these updated. I wouldn't be surprised if they're updated in the next few days for the new iPad and for the iPhone 5. But this is the first place I would check. Apple obviously has the most experience with this, and everybody starting out should just use a lot of these recommendations. So now we know the stream count, the resolution, and the data rate. How do we customize other encoding parameters for adaptive streaming? And there's three areas: keyframe settings, bitrate control, and audio parameters. We kind of touched on two. This keyframe interval, the key thing here is the keyframe interval has to be the same in all the files because you're switching from stream to stream, and you have to start playback on a keyframe. And the keyframe interval has to be regular, right? You can't use keyframes at scene changes because that could interrupt the regularity of the stream. What we want is a keyframe at the start of this chunk, a keyframe at the start of this chunk, a keyframe at the start of this chunk. Because if you don't have that all through this, the chunk won't play, right? Because you have to start playback on a keyframe. So the way to accomplish that is use the same keyframe interval for all iterations and disable scene change detection. In terms of bitrate control, most of us are familiar with CBR versus VBR. VBR is variable bitrate encoding. CBR is constant bitrate encoding. CBR is more conservative, produces a single consistent stream, but oftentimes the quality is inferior to variable bitrate encoding, and sometimes it's noticeably so. So this is the same file. This is encoded with constant bitrate encoding, and we can see that the data rate stays pretty constant throughout the video file. And this is one particular file, one particular frame right after a transition from the camera facing down that looks at his painting and the camera facing him. So it doesn't look like a high motion scene, but it is a high motion scene. With constant bitrate encoding, we get a consistent bit stream, but this particular frame is pretty ugly. With variable bitrate encoding, we get a stream that responds to the complexity in the video, but we have a stream that, that's very irregular. So what happens when the iPhone or the iPad starts to retrieve video that's a high bit rate. Okay? When it's coming along fine, it's processing all these frames, and then all of a sudden the bit rate goes way up. Now, remember we talked about the fact that these iDevices switched streams based upon buffer status. So if all of a sudden the data rate goes way up, you could be triggering stream switching just because you use VBR as opposed to CBR. So that's the concern. You know, this gives you a file that's very easy to retrieve in regular chunks. This gives you a file that looks a little bit better, but could cause inadvertent stream switching because you have high data rate chunks like these. And that's kind of the VBR versus CBR argument. I've done 5 or 6 consulting projects relating to adaptive bitrate streaming. The first 3 or 4, I took the conservative route, and I said, let's just use CBR. Let's get it working. Maybe the quality will suffer a little bit, but let's make sure it works smoothly. And then the last few, I've started to use what's called constrained VBR. So with constrained VBR, you set the target bit rate, but you also constrain the maximum data rate. So if you set it at 150 maximum, perhaps the target is here, and you don't see data spikes over here. Okay, so you have the ability to adjust to scene changes to a degree, but you don't really spike the data in a way that's going to guarantee a stream switch when you don't really need one. So if you're going to use CBR, that's the most conservative. If I'm just starting out, I'd strongly consider that. If I want to go to VBR to make sure I get at least pretty good quality throughout, I make sure I use constrained VBR, and I constrain the maximum data rate probably to between 125 and 150, or up here I go to 200. Just make sure it's constrained. Just starting out, I probably would use 150, 150% of the maximum is the data rate. In general, you know, the audio parameters, we looked at this as well. Apple clearly recommends using the same audio parameters throughout. Why? Because some producers apparently reported audio popping when you switched streams that use different audio parameters. Now, I myself have never experienced that. I did an article a couple years ago for Streaming Media where we talked to a bunch of producers using these technologies. Most switch the quality of their audio streams along with the video. So MTV, obviously they care about the audio quality. They use different audio parameters, you know, for their higher quality video files than for their lower quality video files. So if you're gonna configure this and audio is important, then that's something I would try, but I would also, during testing, make sure that I didn't hear any audible popping when the streams were switching, okay? If I did that, I would switch from stereo to mono at the same per channel sampling rate and bit rate. So for my lower quality streams, I would use 64 kilobits per second, 44 16-bit, and then for my higher quality streams, I would just turn that into a stereo feed. But I would keep 44 and 16-bit. I wouldn't go from 8-bit to 16-bit. I wouldn't go from 22 to 44. I would just keep these identical and then switch the channels and the data rate. And then, of course, you would test. You know, if you're doing a talking head, none of this matters. You can use 40 or 64 kilobits per second mono, and nobody's ever going to hear the difference. If you're producing the London Symphony Orchestra, you really do want to use a higher quality audio feed because the quality will reflect that. Okay, so the reality is nobody's producing, or I don't want to say nobody, but very few producers are producing solely for iOS devices. Everybody's producing both for desktop playback, which can't use HLS, and for mobile. So what are your alternatives if you're producing for Flash and for HLS? Well, you've got 2 alternatives. Number 1, you can produce 2 sets of content and manifest files, right? So you can produce a set for Flash and a set for HLS. Or you can create 1 set of files that's transmuxed by a video server like the Wowza media server, the Adobe media server, pretty much every media server out there now, I mean, we'll look at a list in a second, can take in one stream, whether it's MPEG-2 stream, whether it's HLS stream, whether it's smooth streaming stream. It can take in a single stream here and then transmux the file for delivery to alternative adaptive streaming configurations. Now, when I say transmux, what do I mean? So let me hate to skip around, but this is kind of useful. So if we go back to this slide here, what we have is files in the MPEG-2 transport stream container format. They're H.264 encoded files. Okay, so it's H.264 in an MPEG-2 transport stream. And then we've got manifest files that contain address information for where the files are, for telling the iDevices where to retrieve the file. So what happens during transmuxing is we don't convert the H.264 video file, we just change the container format. Right? So we change it from an MPEG-2 transport stream to the F4V format, which is what Adobe uses. So we don't re-encode the file, we just change the header information to change the transport stream. And then we convert the index file here that really is just a list of locations and file chunks to the manifest file that Adobe needs. So going back to this slide, basically it's a real-time conversion because they're not really doing any heavy re-encoding, they're just changing the container format and changing the manifest file. So if you're looking at supporting multiple devices, find a server that can do it. So Wowza was the first to do it. I think it was a brilliant innovation on their part. Microsoft can do it. They can take in a Silverlight stream and output a stream for HLS delivery and for smooth streaming. Adobe can take an RTMP or an HDS, HTTP dynamic streaming. They can take that input and then push out a stream for HLS delivery and also deliver to Flash desktops. And then the real Helix server can do the same thing. So today, you should never have to produce two separate files for delivery to the two alternative platforms. You should just find a service provider who can transmux those streams for you. So transmux is the key word. Transmux basically is shorthand for we're not re-encoding, we're just changing the container format and the manifest file format. And then the obvious key point is, desktop players like Flash can play back video using the high profile. Okay, so the whole profile thing we started with at the beginning of this hour basically said you have to customize your encoding parameters to match the target platform. On one hand, for computer playback, they all can play high profile. For mobile playback, the lowest class can only play baseline profile. So if you're encoding one set of files that are going to be transmuxed, you have to make sure that the lowest iterations are encoded using the baseline profile. Now, what's the quality cost of baseline versus high? The work that I've done, and I can show you a link if anybody's interested in that after the session, come up and I'll show you the link. It's on my website. I saw very little difference between main and high profile, and baseline, main, and high profile. So I think it's if I'm producing for, and I did the work for a client. They basically asked the question, look, I can use transmuxing, but am I losing any quality for desktop playback because I'm encoding using the baseline profile instead of the high profile? And we did the work, we compared the files, and there was very little quality difference between the files. So at this point, you can encode baseline for those lower quality iterations and not really worry about losing quality on the desktop. A couple of other useful technologies that are coming available at this time. Live transcoding. So we talked about transmuxing. We're not re-encoding. We're changing the container format in the manifest file. Live transcoding is a single H.264 file in, and then re-encoding that into different adaptive streams. So if we were producing this event live, and the outbound bandwidth from this facility was limited, say to 2 megabits per second. 2 megabits per second is the only stream we can get out. Tough to do that adaptively, right? So what you can do with live transcoding is send that 2 megabit per second stream out to a server, and then the server can re-encode in real time, produce 4 or 5 iterations of that stream, and then transmux those as necessary to serve multiple targets. So I think it's a very elegant way to handle live events when you're at sites that don't support the bandwidth necessary to push adaptive streaming out. Reduces your outbound bandwidth requirements. That's always tough at any facility, and reduces your encoding costs, because otherwise you'd have to have a encoder on site that can encode multiple streams. Costs a lot more than a single stream encoder. The Wowza transcoder does this on a server, and in the cloud, Zencoder, recently purchased by Brightcove, they do it. Hivision, they're here at the show, they've got a tool that can do it. Sorensen can do it, and Wowza can also do it in the cloud. So it's a cool way to produce an event live and create streams for HLS delivery and flash delivery very efficiently. Okay, so all that was HTTP live streaming. Some people won't use that. They just want to deliver a streaming file, single streaming file to a remote iDevice. You know, obviously, if you're not using adaptive, you can offer a high-quality stream for that iPad, but it's not going to go through to people connecting with iPhones and cellular connections. Or you can produce a lowest common denominator stream that plays everywhere that doesn't look good. Or you can do multiple streams that are selectable by the viewer. You know, click here depending on your connection. And then these are file recommendations that I pulled from the Apple HLS recommendations. You know, if you want to produce a iPad-only stream that's got a pretty reasonable data rate, probably still will play on some iPhones, this is what I would recommend. If you want a low-quality stream that should play everywhere and should be deliverable everywhere, this is what I would recommend. And if you had to pick one stream that would play everywhere but still look pretty good, you know, this is the configuration that I would recommend. There's the pitch. That's the end. Any questions?
Actually, 2 questions. Wait for the microphone. Yes, great. Actually, 2 questions, Jan. First, is there an explanation for short videos, like music videos, having 256, but the very moment we are talking long videos, like TV shows, that they actually stick to the 160? Might the content length be an issue for that producer's decision, or is it a storage consideration, a file size consideration?
Yeah, I missed the first part of your question, I'm sorry.
If you compare the short videos towards the long videos, 256 kilobit audio versus 160 kilobit audio, because that was the kind of the thing that stuck out to me. People producing short stuff are going above the 160 recommended by Apple, and people producing long stuff actually stick to the 160. And what is the reason for that one?
Yeah, I mean, I would characterize that by saying that the people who produce music videos went to 256, and pretty much everybody else stuck to under 160.
Isn't really.
I wouldn't see that as. I think it really was more you're producing a music video. The audio has a much higher value than many other podcasts.
The question would be regarding live versus VOD. Do you see any big differences in people producing HLS for actually live or HLS for VOD in terms of encoding rates, aspect ratios, bandwidths, whatever?
I don't think so. I mean, you don't see separate recommendations from Apple. And I've looked at the numbers or the configurations that Turner uses for some of their PGA broadcasts, and they don't seem much different than what you see from the Apple recommendations. So I don't see a lot of difference.
And any thoughts on the original audio sampling rate? Because I saw that you had some slides up there with audio at 44 kilohertz, whereas a lot of TV content, the source audio is at 48 kilohertz. Any thoughts on which works better once you actually get it to the end consumer, if anybody can actually hear the difference?
Yeah, good question. There's I don't know if this is urban fiction or if it's a real problem, and actually there's a Brit, Andy Stevenson, works at one of the colleges who had a problem broadcasting 48 kilohertz audio to Flash player. So my recommendation for Flash is always 44.1, because if you look at the specs for the Flash player, it's 44.1. And if you send it 48, it's got to do the conversion from 48 to 44.1 in software, which in his case introduced a synchronization issue. So I would, if I was producing one file for delivery everywhere, I would use 44.1. Any other questions?
This may be a little basic. My understanding is that HLS can sort of be streamed off of regular sort of HTTP web servers, but not Smooth or any of the other formats. Is that correct? And that you need an iOS server for Smooth and so forth? And is there a big cost difference between those?
Correct. And Microsoft would be very upset with you. The difference between HTTP technologies and RTMP technologies is the requirement of having a streaming server. And all HTTP technologies, whether it's smooth streaming or Adobe's HDS, which is HTTP dynamic streaming, or HLS, HTTP live streaming, all can work off of an HTTP server. A couple of aspects to the question, very interesting question. So that's, the reality is they're all HTTP technologies. They can work off of an HTTP server. The reality is everybody has to transmux, right? Nobody's serving one class of player. So the reality is you're probably going to need a streaming server anyway, because it's easier to transmux using a streaming server than to create two sets of files with a typical web server. The other thing is that even though in theory the HTTP technology should be cheaper because you can use no streaming server, because it can use transparent caching on the net, therefore send less data. You know, there's a lot of reasons it should be cheaper. So far you haven't seen any price differential between RTMP and HTTP, or streaming server versus non-streaming server. Even though there's no cost of the server, you know, all that stuff, there's been very little, if any, price differential. Now there are people saying that RTMP delivery is, a lot of the major CDNs are trying to stop supporting it, but you know, that's something to watch in the future. But I think it's more relevant to say, look, most producers who are serious about this are going to need to transmux, so you're going to need a streaming server anyway. An HTTP server can't transmux.
What about edge packaging? There's some solutions that kind of, I guess they're more operator-oriented, but they do the encapsulation kind of at the edge or the transmuxing at the edge.
You know, I've not worked with any of those. I've heard of the solution, but I don't have any familiarity with it. Any other questions? Okay, we're just about out of time. Thanks for your attention.